Hi, I'm Gordon Half, Cloud Evangelist with Red Hat, and today's topic is operating system containers, what they are and why they're interesting. Before I go on to containers, let me very briefly review what virtual machines are, what we tend to call server virtualization is. I know this is going to be very basic for a lot of you, but I think it's worth doing just so we have context to talk about containers and how they're different. Let's first take a look at virtualization. So you've got a server, see, server. Then you have something sitting on top of that called a hypervisor. We'll call it H right there. And what that hypervisor is doing is it's basically putting this layer of abstraction on top of the server. So nothing sitting up above there really sees this server any longer. They see a virtual representation of the server as the hypervisor cares to share it. So now you can run virtual machines on top of that hypervisor. So there's a VM, and this is an entire operating system contained in here, so a guest OS. Now, because there's an entire OS in that VM, the other guests on top of here don't actually need to be the same thing. So we can have a different VM, we can even have a third different VM, and so forth and so on. Now, the disadvantage of this approach is that by having a complete operating system essentially around the application, you're carrying a lot of overhead essentially for each of those virtual machines. Contrariwise, the advantage is that you do have a complete OS, so each one of these things, as I showed here, can be different from each other. It doesn't need to be, there's no relationship between the virtual machines here, and in fact, the hypervisor puts up a pretty substantial wall in between because, at least to a first approximation, as far as the VM is concerned, it has an entire physical server all to itself. Now let's talk containers. Containers have actually been around for a while, but they've never been terribly popular in enterprises, although they've been used fairly extensively at hosting providers. So let's look at what a container is. You still have your server down at the bottom, right here, big S. Things don't run too well without hardware. But then, rather than having a hypervisor sitting on top, you basically have a nice big operating system, OS, like Linux, and why we will run anything other than Linux. Now, rather than running guest instances, guest operating systems on top of here, what you really have are resource groups within the operating system. So we have our application here, and from the operating system's point of view, this is a bunch of processes, execution entities. And in fact, historically with Unix and Linux, you could do various types of management of these process groups. So things like C groups in Linux, for example, let you specify the amount of network, the amount of CPU, the amount of storage, and so forth that those individual groups of processes can have. So what really happens with containers is that you take that same basic concept, and in fact, containers implementation on underlying OpenShift platforms as a service, for example, uses C groups, and you combine that with some other things. You may very well combine it with SE Linux, as Red Hat does with OpenShift, to provide some additional security isolation around these resource groups. And then furthermore, you do various types of namespace isolation so that that application, that instance, running in that resource group thinks it has an entire server to itself. But the difference here is that everything is happening within an operating system, and one of the big advantages here is that means this operating system, which is very good at managing processes and groups of processes, has visibility into each of these entities that are running on it. And that creates a lot of advantages in terms of efficiency, the speed with which instances can be started and stopped, and so forth. So to review, with containers you have a relatively homogeneous environment. All of the guests are running on a single operating system kernel. So they all have to be running in the same operating system kernel version. What you get in exchange for that is a much lighter weight implementation of being able to run multiple guests. And this may be an advantage or a disadvantage. If you want to, for instance, update the operating system, you'll only need to update it once, not in every guest OS, which potentially eliminates or at least greatly reduces issues associated with sometimes called VM sprawl. So why are we talking about containers today? Well, when both operating system virtualization and the hypervisor-based approach to virtualization came onto the scene in around 2000 or so, they both had their adherents, but really enterprises coalesced around the hypervisor-based model. And the reason for that is that if you kind of look at relative advantages and disadvantages of the two approaches, enterprises were very concerned about being heterogeneous, and they weren't as concerned with wringing the last drop of efficiency out of their virtualization approach. I'd also probably argue that there was really only a bandwidth, so to speak, for IT shops to adopt one of these approaches, and hypervisor-based virtualization was just a better match. So what's different today? Well, if you look at cloud workloads, particularly in the case of platform as a service, it looks a lot more like a typical hosting provider implementation. So you tend to have very homogeneous environments in terms of the underlying operating system and so forth. In fact, in the case of platforms as a service, the user typically isn't even exposed to the underlying operating system. That's, in fact, one of the benefits of a PaaS from the point of view of a web developer. Therefore, containers look like a lot better match in many ways than virtual machines are, because you have all the density advantages, you have the ability to spin up and down instances very quickly, and the fact that you can't have a whole mix of operating systems and operating system versions doesn't really look like so much of a problem. So we really see containers being an important technology for cloud-style workloads and cloud-style infrastructure moving forward. Thank you. I'm Gordon Happ with Red Hat, and we've been talking about operating system containers. Thank you.